All right, we've got more exponential functions today, functions involving e. Let's see what e is right here. The natural base e is defined as follows, it says. This is the function it comes from, but this is what we need to know right here, the main thing. E is approximately 2.718281828. Basically, e is a number more than 2.5, between 2.5 and 3, 2.71828. It's irrational, never stops, never repeats. That's an estimation for it, hence the little symbol right there. And it comes again from that function. Okay, simplify. Remember, e is really just a number, so we can do all the rules with exponents also apply to e. So part A right here, you have two e's that are multiplied together. You just add the exponents, e to the 7th. Part B, dividing. 12 divided by 3 is 4. You had e to the 4th on the numerator, e cubed in the denominator. Just subtract the exponents, just e. And then part C, have an exponent outside, goes for everything inside. So you square the 5, make it 25. Multiply the exponents, you get e to the negative 6x. Remember, we never leave a negative exponent in an answer, so we're going to flip the e, make it 25 over e to the 6x. And that's all you got to do. All right, use a calculator to simplify these. I'm just going to punch it straight in. If you're looking at your calculator, the E button is right above your LN. There's two buttons above on. So if you hit second LN, the E pops up with an exponent. Just hit 4, enter, and you should see 54. Oops, 54.598. And the next one, same button, second LN or natural log, E to the negative 0.09. Hit enter. You should see 0.9139. You may want to punch those in real quick. Make sure you got the same thing I got. Make sure you find that button under calculator. All right, natural base, so if you graph them. Now remember what E was. E was 2.71828, which means E is actually exponential growth. If you just see an E and you have a positive exponent, it's exponential growth. If you see E with a negative exponent, remember negative exponent flips things. So if you flip E, it becomes a fraction, which means it is exponential decay. So an E with a positive exponent is going to be growth, just like this. E with a negative exponent is going to be decay, just like that, like we did the last 2 days. Same stuff is true. Passes through 0, 1, usually, unless it's been shifted. We're going to plug in one more point. We'll plug in one past that one and see what happens with the graph to get us a good idea what the graph looks like. But remember, positive exponent, growth, negative exponent, decay. All right, graph, state the domain and range. So this one, it has a positive exponent right there. And because it has a positive exponent, what that tells me is that it is exponential growth. So that's what it's going to look like. I'm always going to put a 0 in first. Just makes the exponent become 0. E to the 0 is 1. 1 times 3 is 3. So instead of it going through 0, 1, it goes to 0, 3 because it's been stretched by 3. Go ahead and plug 1 in. I'm going to punch it in my calculator. If you plug 1 in there, it'd be y equals 3 times e to the 0.25 power. And I got 3.85. So I punched in 1, I got 3.85, which is about right there. So if I connect my dots, the exponential growth function will look just like that. Remember, the x-axis is still an asymptote. Everything else is still true. All right, let's go one a little more complicated here. First of all, I notice it has a negative exponent. Let me blow it up for you. It's got the negative exponent right there, which means it's going to be exponential decay. I also notice it has a +1 at the end, which means it's been shifted up 1. So I'm going to go ahead and move the asymptote up 1. There's my asymptote. Usually I'd have a point right here, 1 above it, but it's been shifted right 2 and up 1. I've already shifted up 1, so I'm going to go right 2 from there, which will put me here, which that point is 2, 2. So let's check it here. Let's plug in a 2 and make sure we get a 2 when we plug it in. If I plug 2 in that parentheses, 2 minus 2 is 0. 0 times 0.75 is 0. Anything to 0 power is 1. 1 plus 1 is 2. That's perfect. 2, 2 does work. Now, because it's exponential decay, I'm going to go the other way. I'm going to plug in a 0, just because I think it'll be easier. And I'm going to plug that in my calculator right here. If I plug a 0 in there, that would give me, where the x is, e to the negative 0.75 times negative 2 plus 1, and it gives me 5.48. 5.4, so 0, 1, 2, 3, 4, 5. So somewhere about right there. Remember, it's exponential decay, so my graph is going to come down this time, getting closer and closer to that asymptote, going through those 2 points. Now, I forgot to domain and range last time. Domain all day, negative infinity to positive infinity. Domain is all real numbers. The range is going to be y is greater than 1, or you could write it this way, 1 to infinity. Either way. Okay, another interest formula here. It says continuously compounded interest. Anytime you have interest is compounded continuously, and it will say that in the problem, we're going to use what's called the PERT formula. A equals P e to the RT power. P, again, stands for principal. E is E, the number E, 2.71828. R is the rate you're getting. And T is time. So same stuff the other day, except we have E now. Let me show you one example. It says you deposit $4,000 in a savings in an account to pay 6% annual interest compounded continuously. That's how you know how to use this formula. What is the balance after 1 year? So I'm using this. I'm using the amount is P e to the RT power. The principal is what you start with. We start with $4,000. So I'm going 4,000. E to the RT. The rate is 0.06. And this time the T is 1. So, I'm going to punch that straight in as I see it. My calculator, 4,000. Second element to get my E, parentheses, 0.06 times 1. Don't really need the times 1 part because it's 0.06. And I got 42, 47, 35. You may want to punch that in as you watch this and make sure you get the exact same thing I'm getting, because you're going to have to punch some in tomorrow. All right, and that's it. That's the E. E is a cool number. Used a lot of math. The higher you go in math, the more you're going to use this E as a base. So it's called the natural base. And we'll see you tomorrow when we work on much more of these. So see you then.